Hey, pre-calculus, I've got some video notes for you. This is 2.2. We're going to call it lesson number 1. It's basically covering the content from number 1 through 24. Basic idea of how to sketch graphs. So the first thing I'm going to do is talk about example number 7. So when you look at number 7, let's get some stuff off to the side here. You get 2x squared minus 1 equals the y value. So what you can do here is you can make a table of values. If you know what parabolas, these quadratic structures look like, you're way ahead of the game. I'm just going to say you can always plot points by picking x values, inputting them here, and then getting out of it a y value. So let's think of a vertical table like this, where you got x's on the left and y's on the right. So let's just throw smack dab in the middle, checking x equals 0, because a lot of times x equals 0 is an interesting value. So all we're doing is we're saying plug 0 in for the x right here. You get 0 squared, which is 0, times 2, which is 0, minus 1. You know that the point 0, negative 1 is a point for this equation. This equation yields the data point 0, comma, negative 1. So there's our first point. Now I'm going to plug in 1. 1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1. I got a second data point. The data point input 1, output 1 works for y equals 2x squared minus 1. And then you can just kind of continue with this. You plug in 2 here. You get 7 as an output. So input 2, output 1, 2, 3, 4, 5, 6, 7. Now, in this section, we're also going to be talking a little bit about symmetry. And what you should be aware of is that quadratic equations, specifically this kind of parabola right here, is going to be symmetrical wherever its vertex is, wherever its low point is. So if you weren't aware of that, you can still just keep plotting points. If you go to 3, it's going to give you 17 quick, and it's going to be approaching infinity very, very, very quickly. So it might be better to go in the opposite direction and test negative 1 for x. Negative 1 squared is positive 1 times 2, 2. 2 minus 1, positive 1. So that symmetry I was talking about, our vertex is actually right here for this particular equation, which means any point I plot 2 away in this direction is going to be the same if I go 2 away in that direction. And you got your graph. So that's what number 7 looks like. Check out number 11. Number 11 gives you the equation x equals negative y squared plus 5. Now they literally turned the tables on us. It used to be equations are always y by itself. In this case, x is by itself. So here's the main difference. If x is by itself, I'm going to rewrite my table. And this isn't a standard thing to do usually. I'm going to put the y value in the left spot. Up and down is still the y-axis, okay? I'm just going to look at it this way so that there's no plug-in confusion. All right, so again, I'm going to go to 0 to be my start. 0 squared is 0. Negative 0, still 0. Plus 5, 5. So here's the difference. I'm plotting y equals 0 when x equals 5. So it's technically the ordered pair 5, 0. All right? a little bit confusing, but I think you're following me based on how I labeled my table. So if we tried 1, oh, this is kind of tricky. The negative is, you got to do the exponent to the 1 first. So 1 squared is 1. What's the negative of that? Negative 1. Negative 1 plus 5 is 4. So it's x is 4 and y is 1. So you'd go over 4 up 1. Again, keep going. Try 2. So 2 squared is 4. Make it negative. Negative 4 plus 5 is 1. So over 1 up 2. And that trend keeps continuing. I mean, I could try again. What is y equals 3? Well, 3 squared is 9. Make it negative. Negative 9 plus 5, negative 4. So, excuse me. So you'd go left 4, up 3. And as you check this out, it kind of looks like if you tilt your head to the side, it's like the same shape I just drew. It's like a parabola, but sideways. So I think you can see what's going to happen when we go negative. So if it's a negative 1 for the y, I'm still squaring it. Something times itself is always positive. Now you take the negative of that, right? If you're having trouble visualizing this, negative y squared plus 5. If I plugged in negative 1, it's the negative of negative 1 squared plus 5. Negative 1 squared is positive 1, but that negative is on the outside still. That's why this one's going to be 4. So an x value of 4 not only yields a y value of 1, but it also yields a y value of negative 1. So 4, negative 1. And if you guessed it, we've got symmetry over the x-axis now. These are partner points as the x-axis splits it up. These are partner points. It's going to be, when you plug in negative 2 for y, you're going to get 1 for the x. Same thing with negative 3 and negative 4. So this is the graph of what x equals negative y squared plus 5 looks like. And keep in mind this too. X equals negative y squared plus 5 also looks like this. If I did a little algebraic manipulation, I could get y by itself. Here's the thing though. If I get y by itself, I've actually got 2 separate functions inside here. One is the positive of root 5 minus x. The other's the negative. So here's the positive version of root 5 minus x. And here's the negative version of root 5 minus x. All right, so I think this makes sense so far. I'm not going to do any more of those, but I'm going to roll through number 23 with you, okay? So here's what 23 looks like. This video is going to be very bare bones, but the content's going to be, just everything through 24. Everything through number 24 on page 102, section 2.2. There. All right, what is going on here? Well, they gave us a functions graph, and they're basically saying as x, this little arrow means approaches. As x approaches negative 1, you notice that little negative that's taken the place of the exponent spot for the negative 1? that means from the left. So this is literally saying as x approaches -1, from the left. So then the positive version would be, what's it doing from the right? So let's just follow this up. Let's pretend we're on the curve, and we're coming towards -1, x equals -1, so on the x-axis, from the left of -1. So we're traveling, we're getting closer to -1 as our x value. All right, and now we're getting closer. Bam, we got x equals -1 here. From the left, what's the value of it? Well, they're looking for a y value. It's 2. So yeah, notice they're saying f of x approaches 2. Y equals f of x. F of x is just a way of saying you input x, you output f of x. You input x, you get y. You input x, you get f of x. So this is actually a fairly simple task. If you're on the curve and you're approaching 2 from the right, here's x equals 2. Its y value is 1. Now let's say they don't give you a direction from the left or the right. Pretty much in order for this function to kind of exist on a good plane, you need to make sure they converge to the same spot. At 3, it's at y equals 4. And then these are a little bit trickier. They say, what's the value of f of x as x approaches infinity? Well, if we just keep going, we're talking in the positive direction forever. If we just keep going right on this curve forever, it just keeps moving up, 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 up. It keeps going up. This is sort of implying that, hey, it's never going to stop. It's going to keep going up forever as your x values increase to the right. So we would say, as x approaches infinity, our y value, or f of x, also approaches infinity. And I'm going to put positive infinity because you're going to see on the next one that as my x values keep going left, it's going to just keep going down, down, down. You keep going left, it goes down forever and ever. It's going down forever. That'd be negative infinity. Your y values are getting infinitely smaller forever. All right, that'll do. I think I'm just going to leave it at that. If you guys need some help on number 22, I'll talk about that in class. But bottom line is symmetry. There's a quick basic test for that. So, thanks for watching, and hopefully you enjoyed this. That's all I got.